Welcome to the DIY Honda Garage channel. DTC P04F0 indicates an issue in the Evaporative Emission Control EVAP system related to incorrect purge flow. The EVAP system is designed to capture fuel vapors from the fuel tank and prevent them from escaping into the atmosphere, playing a crucial role in reducing emissions. The system includes several key components, such as the EVAP canister purge valve, which regulates the flow of fuel vapors, the fuel tank itself, and the EVAP canister. When the powertrain control module, PCM, detects a fault in this system, especially when the purge flow is inadequate during pressure testing, it triggers the DTC. The components in the EVAP system are typically located in the engine compartment, around the fuel tank, and in the car's underbody. This DTC requires prompt attention to ensure emissions controls function correctly and to prevent further issues with vehicle performance or emissions violations. The DTC P04F0 signifies that there's an incorrect purge flow detected within the EVAP system. This situation often arises when the EVAP canister purge valve is functioning correctly, but the expected flow of vapors is not realized during pressure tests. Specifically, the PCM, or Powertrain Control Module, monitors the flow of fuel vapors and triggers this DTC when discrepancies are noticed in the expected operation. The main components involved include the EVAP canister purge valve, which is primarily located close to the fuel tank and is responsible for allowing vapors to flow into the engine for combustion. The improper operation can lead to elevated emissions, making it vital to diagnose and rectify the fault accurately. Understanding the role of each component and their relationships within the assembly will provide valuable insights into rectifying the error. The possible causes behind DTC P04F0 typically revolve around the malfunctioning of the EVAP components. First, the EVAP canister purge valve may be faulty, which directly impacts how fuel vapors are managed. Any blockage in the EVAP purge system could hinder vapors from moving effectively, leading to erroneous readings by the PCM. Leakage in any part of the system, such as the connections between the fuel tank and EVAP components, may also contribute to incorrect flow measurements. The Environmental Leak Check Module, or ELCM, is another critical component whose malfunction could lead to this DTC. Lastly, issues within the fuel tank itself, including damage or improper sealing, should also be investigated. Eliminating these potential causes is essential for proper vehicle operation and meeting emissions standards. When DTC P04F0 is set, the driver may observe several symptoms indicative of an underlying issue with the EVAP system. The most obvious sign is the illumination of the check engine light on the dashboard, prompting the need for further diagnostics. Additionally, reduced fuel economy may become apparent, as improper vapor flow can disrupt the optimal air-fuel ratio. In many cases, the vehicle could also fail an emissions test, which can have significant implications for registration or legal compliance. Lastly, variations in engine behavior, such as stalling or erratic idling, might occur due to the improper functioning of the purge flow system. Recognizing these symptoms early on can lead to timely intervention and prevent more serious damage or complications. The initial step in troubleshooting DTC P04F0 requires the technician to turn the vehicle ignition to the on position without starting the engine. Following this, the Honda Diagnostic System, HDS, should be accessed to perform the EVAP purge flow check test. This test is critical for assessing the functionality of the EVAP system and establishing whether proper vapor flow can be detected during the test. If the test results indicate that the expected flow is not achieved, It confirms the presence of an underlying fault within the EVAP components, necessitating a thorough inspection of related elements. Proper execution of this step significantly influences the effectiveness of the overall diagnostic process, streamlining subsequent inspections. The next step in troubleshooting involves inspecting the EVAP canister purge valve. This component is essential for regulating the flow of fuel vapors from the EVAP canister to the engine intake. The technician should first assess the valve for any obstructions or signs of wear that could cause improper functioning. Following the visual inspection, a functionality test should be performed using a vacuum pump to apply pressure or vacuum to the valve ports. Both the opening and closing functions should be verified to ensure the valve is operating within specifications. Anomalies during these checks could confirm the valve as a source of the DTC, making it a priority for replacement or repair if faults are identified. The third step is to evaluate EVAP Purge System 1, which plays a vital role in transporting fuel vapors from the EVAP canister to the engine intake. Inspecting this system requires looking for any leaks, blockages, or restrictions that could impede vapor flow. Connections between components must be checked for security, as poor connections can lead to vacuum losses. The technician should also inspect the integrity of hoses and fittings to ensure they are free from damage or cracks that could cause vapor loss. Conducting a thorough inspection at this stage aids in identifying potential physical faults that can be rectified swiftly to restore proper EVAP functionality. The fourth step focuses on the EVAP Purge System 2, which also aids in vapor flow management. To perform this assessment, the technician should first disconnect relevant hoses as outlined in the service manual. This disconnection allows for targeted tests, including vacuum application, to confirm system integrity. Conducting blockage tests is crucial by ensuring there are no obstructions that prevent vapor flow. Additionally, conducting leakage checks is important. If vacuum doesn't hold when applied, it signifies leaks present. These assessments help identify faults within the purge systems effectively and form a basis for remedial actions. The fifth step consists of examining the Environmental Leak Check Module (ELCM) system. This system is integral in confirming that there are no vacuum leaks in the EVAP system. A detailed inspection of the ELCM's connections and components is essential to identify any leaks or restrictions that could compromise its functionality. Technicians should carefully assess for any visible damages or points of failure that may exist within the unit. Validating the integrity of these components is paramount, as any discrepancies found might be directly linked to the triggering of DTC P04F0. Addressing these potential issues also contributes to the overall effectiveness of the EVAP system. At this stage, attention shifts to the main flap unit inspection, which oversees the flow of vapors into the intake. Start by ensuring the shutoff valve is completely closed and devoid of any obstructions. Inspecting the sealing surfaces between the shutoff valve and corresponding fixtures is crucial. Damaged or missing seals can lead to vapor leaks. Functional testing of the shutoff valve's operation can illuminate any underlying issues. A successful inspection without anomalies will confirm that the main flap unit is operating within expected parameters, thereby eliminating it as a potential source for DTC P04F0. Following the inspection of the main flap unit, the next logical step is to evaluate the fuel tank system for potential leakage issues. This involves disconnecting the fuel vent tube and applying a vacuum to check the integrity of this section. It's vital to ensure that there are no breaks or loose fittings that could lead to vapor loss. Furthermore, after connecting the monitoring gauge, observing whether the vacuum holds is a key indicator of system integrity. If abnormalities are detected, it will signify a fault within the fuel tank system, requiring repair or replacement. This detailed check is crucial to ascertain that all elements contributing to the EVAP system's efficiency are functioning correctly. The next step is to inspect the EVAP canister for potential leaks. Leaks here can significantly affect the entire EVAP system's performance, so it is essential to evaluate the canister closely. Disconnect all pertinent tubes, plug them securely, and connect a vacuum gauge to assess how the canister responds to vacuum application. Monitoring the vacuum holding properties of the canister will determine if it can retain vapor pressure as intended. If the vacuum dissipates, it signals a leak or an internal failure within the canister. Rectifying any identified issues at this stage will enhance the system's overall performance and help resolve DTC P04F0 effectively. The final step for the EVAP canister involves verifying for any blockages within the unit. Similar to preceding tests, disconnection of relevant tubes and application of a pressure check is paramount. The technician should connect the vacuum pump to the appropriate port and apply pressure, checking for a refusal to hold pressure, which would indicate blockage or malfunction. A healthy canister should respond positively, indicating no such blockage or leaks exist in the system. Conclusively determining that the canister can perform its designed function without issue will be paramount in resolving the code P04F0 effectively. If prior tests confirm normal conditions, the focus will shift to the EVAP leak check module, which may also be the source of the DTC P04F0. The assessment should involve confirming that all other components tested were operating within expected parameters and pass criteria. Conclusion of these checks will solidify whether the remaining EVAP leak check module is indeed the fault point. If identified as the cause, inspection and replacement will be necessary to ensure full functionality of the EVAP system. Resolving this will rectify the main issue and provide compliance with emissions regulations, helping keep the vehicle operating efficiently. After the necessary repairs and adjustments have been made, a crucial final verification step must be undertaken. This verification includes a thorough recheck of all components that were either replaced or repaired to ensure they meet the required specifications. Next, conduct a road test to evaluate the vehicle's performance under typical driving conditions and to observe if the check engine light remains off. If everything checks out correctly and the vehicle performs as expected, the next step is to clear the DTC using the Honda Diagnostics System HDS and confirm that the fault has been successfully reset. This ensures that the EVAP system is now functioning optimally, providing assurance of compliance with emission standards moving forward. Preventive maintenance plays a vital role in ensuring the longevity and efficiency of the EVAP system. Regular inspections of all components should be conducted to ascertain that they show no signs of wear or malfunction. Pay special attention to the integrity of connections, ensuring that all hoses and seals are clean and secure to avoid loss of vapor pressure. Additionally, monitoring for fuel odors or visible leaks can provide early warning signs of potential issues. Keeping the EVAP system in top shape not only reduces emissions, but enhances overall vehicle performance and can prevent costly repairs down the line. In conclusion, DTC P04F0 signifies a prevalent issue within the EVAP system, indicating incorrect purge flow. Addressing this code necessitates careful inspections spanning multiple components, from the purge valve to the fuel tank system. Conducting thorough tests systematically will unveil underlying issues that may be affecting the overall performance of the vehicle. By ensuring that each component operates within specifications, technicians can restore functionality to the EVAP system, enhancing vehicle efficiency and adherence to emission standards. Ultimately, recognizing the significance of processes involved in troubleshooting DTC P04F0 is key to effective Honda CR-V maintenance and retaining its performance for the long term. Please like and subscribe to the channel. See you next time.